All right, hello everybody. Welcome to your next video. Today should be a pretty short one. We are just going to go over a word problem example because no real new material. I guess we are going to talk about what a velocity vector is, even though we did talk about it during our warm-up um, last class. I think it would be last class. Yeah, that makes sense. All right, so we did talk about velocity a little bit, but we're going to just look at it again, and then we'll do an example word problem like you're going to see on your homework tonight. Okay, let's go. So that velocity vector, so this is a combination of speed and direction. All right, so combination of speed and direction. All right, your magnitude, you're not going to see the word magnitude in your word problems. You're going to see speed. Magnitude is going to be the speed in these word problems. All right, and direction, right, that's still going to be your theta, but it's going to give you like north, south, east, west, right? So it's going to give it to you with kind of compass directions, all right? But it's still your direction angle, all right? And so velocity, your velocity vector, it's got the same kind of component form that we would see, which is a general standard vector. But like I said, we're using the word speed and direction instead of like magnitude and theta. So you're going to see it kind of more like this, right? So you're going to have your speed times the cosine of your direction, comma, the speed times the sine of your direction. All right, and then closed component form. But again, it's ultimately the same thing. So it's your speed, which is basically is your magnitude, right? And then your direction, which is your theta, which is we're going to see a lot of like north, south, 30 degrees north of east, like whatever. So that's kind of the only difference in our problems. All right, so let's just look at an example. All right, so a plane in still air is flying directly west at a speed of 250 miles per hour. So even though it doesn't say to do this, I would always recommend sketching out a picture when you're dealing with word problems. So I'm going to draw myself an XY axis. Remember, north, south, east, west. All right. And then obviously there are XY axis as well. All right. So it says a plane is flying directly west. So directly west means we're literally on the negative X axis. Right, so this is 270 degrees, oh no, 180 degrees. What am I talking about? All right, so directly west is 180 degrees. All right, and it says we're flying at a speed of 250 miles per hour. So our speed is 250 miles per hour. All right, so this is our plane. I'm going to call this vector P for plane, not very original. All right, so P for plane. All right, and so putting this into component form, so I know it hasn't said that yet, but I know I'm going to need this. So I'm just going to go ahead and do it. So remember, it's my speed, so 250, times the cosine of my direction angle, which is 180, comma, 250 sine of 180. All right, and I'm going to leave it like that. You could simplify. This is an easy one to simplify. The coordinates for 180 are x is -1, y is 0. So if you want to, you could go ahead and say that this would be -250, and then this would be comma 0, because 250 times 0 is 0. But you don't have to do that. But if you want to, you can. All right. We're going to end up combining things in a second. So we'll have the calculator for some of this anyways, even though this actually is a probably easy one to do by hand. All right. The next thing it says is that the wind is blowing directly south at a speed of 300 miles per hour. All right. or 330 miles per hour. That's some wild wind, 300 miles per hour. Oh no, that is not okay. All right. So couple ways you can do this. All right, so since I have a computer, I'm going to kind of show you what's happening like kind of visually, right? So our wind is going directly south. So that would be directly south. All right. But we really don't want this vector to go here. We kind of want our vector, come here, mouse. Oh, where did you go? Where'd you go? Oh, there you are. Cool. All right, so we're going to be combining these two vectors. All right, so this is directly south, but instead of placing it right here at the y-axis, I'm going to, oh, that wasn't one piece. That's cool. That's all right. I'll take it in 2 pieces. We want to put it at the end of our plane vector. So we still want it to be pointing directly south, but we want to do this at the end of our first vector. So what I also, if you don't have a computer, this is kind of how I do it when I'm doing it on paper. I'll take like a pencil or something and kind of sketch out like at the end of my first vector, like a little XY axis. And then I'll use that to help me draw my second vector that I'm adding onto the end so that it can kind of help you figure out the correct angle to draw the vector. All right, now if you are doing this digitally, then obviously you can do what I did. You can just draw the vector in the direction it's going, and then you can just drag it over to where you want it to go. But we don't all have that luxury, right? So what you would do instead is you would kind of make like a fake XY axis at the end of the first vector so that you can draw your second vector in the right direction. All right, so here's our wind vector. All right, so I'm going to call it W. Now, going directly south, remember I'm using that first vector as kind of like my x-axis right there. So that's 270 degrees is directly south. All right, and we're going at a speed of 30 miles per hour. So 30, and you can put mph if you want to. All right, so now I'm going to make my wind vector. So here's my wind vector. All right, magnitude is 30, cosine of 270, 30, sine of 270. Now again, this is another easy one to use unit circle value. So at 270 degrees, you have x is 0, y is -1. So you actually basically get the exact opposite of our first vector. So this would be 0, comma, -30. Not degrees, just -30. There we go. All right. So that one's kind of, this is actually like a nice one. Okay, so then the instructions say, find the resulting velocity, speed, and direction of the aircraft. All right, so our aircraft is what's connecting. Remember, when we add, it takes the starting point of the first vector and the ending point of the second vector. So this is our resulting velocity. So this is when we combine the plane's set trajectory and the wind's set speed and angle to get this new speed and direction. So this is like actually what we would be flying in the direction of. All right. And I'm going to call this R for resulting, whatever. All right, of our aircraft. So this is going to be addition, right? We're adding, we're combining, right? Anytime you take one vector, line up the second one to the end of the other one, and then connect from the beginning to the end. This is addition with vectors. We went over this last class. So vector R, which is going to be P plus W, is -250 plus 0, comma, 0 plus -30, which is going to give me a nice, beautiful -250, comma, -30. All right, so that is our resulting vector, all right, our resulting velocity. All right, so that's how you would do these types of problems. All right, so find the resulting velocity, the speed, and the direction. So if I don't know if this one actually wants us to find specifically the speed and the direction of this aircraft, but we can do it easily. So let's just do it real quick. All right, it's a nice refresher on how to find speed and direction. So speed is going to be our magnitude. So if we want to find the magnitude of this vector r, remember that's the square root, and then it's Pythagorean theorem. So 250